All right, welcome. Just two quick slides here just to give a little bit more examples. What rate would you need to invest at to triple your money in 15 years? So I'm using A equals PE to the R times T. And I'd like to jot down the things I know. T is 15. It says what rate, so that's the thing I'm looking for. I'm talking about tripling my money. So if I say that my principal is 1, the amount in my account after that time will be 3, because it's going to be 3 times that. It doesn't matter what number you used for P, because what's going to happen is you're going to have the same ratio. In order to be calling it triple, you would need to have the same ratio of A to P. So 3 equals 1e to the 15r, or just 3 equals e to the 15r. In order to solve this, we need to get rid of e, so we introduce natural log. We get 15r equals natural log 3, so r equals natural log 3 over 15. In my calculator, that gives me approximately 7.3%, and that makes sense. Again, that's logical. I mean, it's a little bit high of an investment rate, but you're trying to triple your money, so oh well. At that rate, so using that 0.07324 that we just got in our calculator, how much would $1,000 be worth after 10 years? So I'm not using this formula now. I'm still using A equals PE to the RT, but now I want T to be 10. I'm putting in an initial amount of $1,000, and my rate is that 0.07324. So I'd have A equals 1,000 E to the 0.07324 times 10. All I do is shoot that straight in a calculator. There's no solving to be done there. I get A is approximately $2,080.08. All right, so that's just a little bit more example of continuously compounded interest. So now we'll do a little bit more with that exponential form of talking about possibly decay, growth, but we can use these a little bit different. So we're taking it sort of out of the context of a problem here. Find an exponential model in the form y equals ae to the b times x to fit the following points. So in this question, what I have to do is realize that when I give you points, I'm giving you pairs of x and y that are on this graph. So I'm going to use this first one mainly because it has 0. And I'm going to substitute it into this. So I'll have 2 is equal to, so y was 2, I don't know what that is, e to the b times x, where x is 0. So here I used x comma y, 0, 2. Now b times 0 is 0. E to the 0 is just 1. So I know then that a equals 2. Knowing that a equals 2, I'll now use this other coordinate and substitute 2 in for a. So I'll have 5 for y equals 2 for a, e to the b times 1 for x. That gives me 5 equals 2e to the b. So 5 halves equals e to the b. And if I'm trying to solve for b in this case, what I have to do is get rid of the e, which means I'll introduce natural log. So I'd get natural log of 5 halves equals b. The problem doesn't specifically just ask for you to find a and b. It says to write an exponential model in this form. So y equals a, which is 2, e to the natural log 5 halves times x, or x natural log 5 halves. This is all the exponent. All right, another example of that same question. Find an exponential model in the same form as above to fit these points, xy, xy. So again, I'm going to start with the one that has 0, and I'll have y equals ae to the b times 0. All of that just gives me 1, and y was 4 in this case, so I get 4 equals a. Using that, I go and substitute in. So 2 equals, A is 4, e to the b times x is 1. That gives me 1/2 equals e to the b. So natural log of 1/2 equals b. And if I'm writing that equation, then I get y equals 4e to the x times natural log 1/2. Usually we put this x in front. It's just so that it doesn't, if I write it the other way, well, I'm trying to write it 4e to the natural log 1/2 x. I can't tell right now if I'm taking the natural log of 1/2 or the natural log of half of x. And the x is supposed to just get multiplied times the natural log. So it's not very clear as to what I'm taking the natural log of. So you'll want to put that x in the front. Final answer. All right, thanks for watching. If you have any questions, come in, get those answered. Otherwise, get started on some of that bookwork.